Last time looking at how we can create a .NET 9 worker service and launch it from a .NET Framework WPF application and communicate between the two using this idea of anonymous pipes. And as I promised, what we're going to do this week is fill in all the gaps to get that full SignalR application working, so that once we finish this, we can have our framework application communicating via the worker service to a .NET 9 SignalR hub, and therefore communicate to all the other different types of client we've seen. So we can have, for example, our framework WPF client talking to a .NET 9 Blazor application and other combinations as well. So let's get on and do that. And so last time, remember, we had this SignalR worker, and all we'd set it up to do was receive a message from the WPF application, which you picked up here, wait for 1 second, and then send that back. And then in our WPF application, we got this worker service proxy, which when we clicked the button, did this send message. So that sent the message out. So that was the one that was received here. And then we had this separate task that waited for the message to come in and displayed it. Let me just quickly run that up to show you. So we had that. Remember, we've got prompted by that sub process to see if we want to debug it, but I don't want to, so I'll just cancel that. And then there we can see the window for that process. There we can see the WPF. And if I type hello in there, then it waits a second and then we get the message coming back. So that's where we were. So now we need to fill in all the gaps with all of that. So let's get started on that. So what I'm going to do, this work service proxy is actually going to completely replace the hub connection and the hub proxy that we currently had when we were directly communicating from our WPF to the SignalR hub. So that's what we're going to do. So basically, I'm going to go to each of the places where we had the hub proxy and put in the work service proxy. And I'm going to start that just with the two messages that are going out. So with the register, which we've already changed a little bit, so I'm going to change that again. And so here, I'm going to get rid of that send message because that was just temporary and bring this back in. And then I'm going to, instead of the hub proxy, I'm going to say the worker service proxy, and then invoke and register player name. And the way this is going to work, it's no longer going to be asynchronous, so we'll get rid of the async there, and we'll get rid of the await there, and we will generate a stub for that invoke. And then we're also going to do something very similar on the throw hand. So here we've got another one of those invokes. So let's put that in there, and again, get rid of the async and the await. And then we've got a slight problem in terms of the number of parameters, but we can see the way to fix that. If we go to the definition, we're going to make it have variable parameters. So let's change the name of this to method, because that's the method we want to invoke on the SignalR hub, so throw or register. And then instead of just having the one parameter, let's make that a params array of string, and we'll call that args. And that now will be happy with both the overloads we've got there. And then what we're going to need to do with this is use this to send a message to our worker service. So the way we're going to do that is on the stream out, remember. Let's get rid of this send message now because that's no longer being used. But what we're going to do here, we're going to say underscore stream out dot write line. And then I'm going to need to use JSON. So I'm going to get hold of the JSON serializer in there and then say dot, just get hold of the right one. So I'm going to use the Microsoft one here. So pop that in there. And then we can just say serialize. And then I'm going to use an anonymous object. So I'm going to say new and then just pass in method and args. And that will send the message off to the worker service. So that's simple enough. Now let's get ready to receive that. So back in our worker service, inside the worker, well, we're already picking up that message. We don't need the await anymore. That was just to show what was happening. And what we need to do then is deserialize that. Now, deserializing to an anonymous object is not really something you can do very easily. So what we're going to do is add a type in the worker that matches what we had there. So we're going to have a new class, and I'm going to call this request for the incoming request. And then I'm just going to give that a couple of properties, a required string. Remember, we're in .NET 9 now, so we've got to worry about nullable types, which we didn't have to in .NET Framework. Call that method. And then I'm also going to have a prop of type string array that I'm going to call args and just initialize that to an empty collection. So that now is something that we can deserialize to. And so back in here, I'm now going to say var request equals, and then JSON serializer dot deserialize. Then we have the generic for the request, which is why you can't do it with an anonymous type. And then we've got the message in there. We've got a slight problem about nullability there. This could return null. If it does return null, all I'd normally do is say if message equals null and then just continue. So we'll just go back round the loop again and wait for the next message if there was some kind of problem there. So that's what we've got there. We then also have a similar issue that the deserialize can return a null reference. So we're going to do if request equals null. We're also going to continue there. Shouldn't really happen, but we need to avoid those warnings on null references. And then we can start making some use of this. And what we actually want to do is simply take the data from this message and send it off to the SignalR server. So we need to actually put that in there now. So next thing we're going to do in here is add the SignalR client that we've been using in other examples. But remember, this one is going to be the SignalR core client because we're now working in .NET 9. So we'll just go for signalr.client. And so that's the same one. You can see version 9 we used in the first WPF example. So we'll have all of that in there. And then we'll go back to our worker. And in here, I'm going to pop in that private read-only hub connection and call that underscore hub connection. And then we can initialize that once again by nicking some code from one of the earlier ones. So let's go to our original WPF client. So remember, this is the .NET 9 one. And if we look in the game view model there, and then if we just get hold of that connection there, and we can put that in the constructor here. And so that's created our connection, and that's already got the appropriate URL. Again, we should be configuring that, but I'm not going to complicate this with using an app settings file. But having done that, we then remember got to start that. So in here, we can put an await, and then we can have a underscore hub connection dot start async, and that will get everything going. So that just happens once when we enter that execute async. Then we need to make use of that. So what we've used previously, if you look again at something like the game view model in there, we did the sends using send async. And send async, you can see, has various overloads for the different number of parameters that we want. That's a bit fiddly here because we've not got those parameters as separate things. We've got them all in this array of strings that we have there. And so breaking that down into different overloads is quite tricky. However, fortunately, those send asyncs are just extension methods, and the method that does the real work is another one that we've got. So on our hub connection, although you can see we've got the send async with its various overloads, we've also got this send core async, and that one takes that array of objects that you can see there. And so that's going to work fine for what we've got here. So the method name we know is request.method, and then the args is request.args. And then the cancellation token, well, not necessarily going to be very important, but the general rule is if you've got a cancellation token, then just pass it on just in case it comes useful. And obviously put an await on there. Just remembered one other thing that I need to do. The way the JSON deserialization works, you'll notice if we look back in the work service proxy, it's going to have method with a lowercase and args with a lowercase, whereas we're trying to deserialize it into uppercase. So what we have to do on here is we have to do a new and then JSON serializer options, and then we've got to say property name case insensitive equals true. Okay, so that will just mean it ignores that. That actually, although it will work, is not the most efficient way to do it, because the problem is you create a new object every time you call it. So actually a better way to do it is to grab that and remove it, and then at the top here I'm going to put in a private static read-only JSON serializer options, JSON options equals, and then all of that, and then we'll just pass that in, and that will save recreating it every time we use it. So that's that part of it. That should now be sending our requests correctly over to the hub. Let's give that a quick test. So what we're going to do is change our startup again. So now we're going to configure startup projects, and we want to start the framework client, but also the SignalR, which is the .NET 9 SignalR, Remember, we don't start the SignalR worker because that is started by the client for itself. One other thing I mentioned last time is that when we try to run the WPF client, because it doesn't have a reference to the SignalR worker and therefore doesn't have a dependency, the SignalR worker won't build, and therefore we had to build it manually. Now, actually, there is a way around that where you can have a dependency without having a reference. And the way you do it, right-click on the solution, and then you need to find project dependencies. And then what we want is that from our framework WPF client, we have a dependency on the SignalR worker. And so if we do that, that means even though there's no connection between them, when we run with that as one of our startup projects, then it will build both of them and that'll all work fine. And again, I'll cancel that. I'll drag over the WPF. We'll put Harry in here, click enter. Doesn't appear to be doing anything, but now if we put Sally in here and click enter, you can see we're playing against Harry. We've not got the behavior hooked up in the WPF, but it's clearly communicating now with the SignalR hub, and that's proved the point really. We've got the communication ultimately from a framework client to a .NET 9 hub going through this .NET 9 worker service. So let's just fix everything else there. So that should handle both of those incoming messages that we had on the game view model. So both of those invokes. Now we've got to start dealing with the messages coming back, which is all of these ons. And so what I'm going to do is, again, take that worker service proxy and use it instead of the hub proxy on the on there, and the on there, and the on there, and the on there, and the on there. So those are the various ones we had. We've got to respond to the won, the drawn, the pending, the game started, the waiting for player. That's what we've got to do. At this stage, we should now be able to completely get rid of our hub connection and our hub proxy. So let's delete that and delete both of those because it should now be doing everything through the worker service. But you can see it doesn't have an on at all. And what you can also see is we've got various overloads for the on. Now, although we could fix the various overloads we had for the invoke, remember, we did that by using a params array. That's not going to work here. We are actually going to have these different overloads. And you'll notice the ones that we need all depend on the parameters to this lambda. So we need one of them that takes a lambda that takes no parameters, one of them that takes a lambda that takes 3 parameters, and one of them that takes a lambda that takes 1 parameter, and one that takes 2 parameters. That should cover everything, and 3 again there. So although if you're doing this completely general purpose, you might go to larger numbers, we need 0, 1, 2, and 3 in here. And so let's start out with the simplest one there, which is going to be our waiting for player. So if we go to the work service proxy, we're going to have in here, we're going to have an internal void on. It's going to take a string, which I'm going to call event name. And then it's going to take simply an action, no parameters, nothing returned, and we call that on data. I'm simply taking these names, event name and on data. Those are what the equivalent names for on the genuine hub proxy were. So we'll just keep them the same there. Let's leave that blank and let's just put the other ones in as well. So although it's not doing anything, everything should be happy. So we need one to have 1 parameter. So we'll call that T1, and we'll also make this generic for T1. And then similarly, we'll do a T1, T2 and a T1, T2, T3. And so that should mean that all of these ons are now happy because they all match up. And that means we shouldn't need to change these at all. We're still going to be calling those lambdas when these particular messages come in and then processing them in a similar sort of way. But what do we want to do with those? We need to make it so that when a message comes in, and this, remember, is where the messages are coming in, we are going to be able to invoke whatever the on data is corresponding to that message. So if the message comes in as, say, game started, then we're going to need to get the on data that we hooked up for game started and invoke that. And so what we need to do is we're going to take this message, and again, we're going to have a class that's going to deal with the format we've got there. So what we're going to do is have another class, which I'm going to call response, even though it actually will look just the same as that request, but it is a response. So in here, we're going to add a new class call this response, and then that again is going to have a property of type string that we call method, and a property of type string array that we'll call args. No need to worry about nullability here because remember in .NET Framework. And so then in here we're going to do a deserialization, and so we can say var response equals and then JSON serializer deserialize response message. We don't need to worry about case sensitivity there, as we'll see, because we're going to be setting up this in a slightly different way. Then we don't need to have that message box anymore. What we need to do is look up whatever action we had based on the method that we had in there. So lookup, obviously we're going to have a dictionary, but what are we going to have a dictionary of? We've got a slight problem that we need to be able to have a dictionary that sometimes contains just an action, sometimes contains an action with one parameter, sometimes two, sometimes three. We don't want to have multiple dictionaries, so we can be a little bit tricky here. What I'm going to do is put in here a private read-only dictionary that's going to have a string, which is going to be the method name, game started, whatever it may be, and then we're simply going to have an action in there that takes an array of objects. So that way we can have as many parameters as we like of whatever type. And I'm going to call that subscriptions, and then we'll just initialize that to the new dictionary. Remember, we're back in Framework now, so we don't get any of those nice initializers that came in C# version 12. So there's our dictionary. And so what I'm going to do here is simply say underscore subscriptions, look up response.method, and then we're going to invoke that. And remember, it takes an array of objects. So we can pass in response.args. Nice example of covariance there, that we can pass an array of strings into something expecting an array of objects. You can have a look at that video on covariance that I did a while back if you want. But that should basically invoke whatever's been registered in these various OMs, except we haven't done that yet. And now we've got a slight problem how we're going to set that up. Well, actually, it's fairly simple, because what we can do is we can say subscriptions, and then in there, it's going to be keyed on that event name. But in this case, we've got no parameters at all. Now, remember, the parameters we want to put in here are going to be the array of objects. So all we do in this case, discard it. And then what we're going to do is invoke that method with no parameters. That'll make a bit more sense when we see the other examples, because here we're going to say, clearly you can't call on data like that. So here we're going to pass in these args, which remember is our array of objects. We know in this case there should only be one of them. So what we do is we pass in args 0, but that's the wrong type, so we cast it to T1, and so that has everything happy. And I think now you should be able to get in the swing of it. For the 2 parameter one, we just have T1 for args 0, and then we'll have T2 for args 1, and then finally we'll have on data, and then just take that one and have T3 and args 2. Okay, and obviously it's a bit of repetition, but it's not really taking much thought, and I think that's about the minimum way you're able to do this with all of that. So that should be everything handled here. So when our game view model, which apart from switching in a different proxy hasn't changed at all, but that's going to pass in, for example, this particular lambda function to the game started, the 3 parameter one. Then in here, that 3 parameter one will be registered under the event name game started, and then when that's invoked, it will pass back the 3 parameters, and that invocation is happening there where we pass all of that in. So that's everything on the WPF side. We've still got to put the work for that in on the worker side, so let's go and do that. So into our worker, and this is actually the bit where we've got to, I think, do the most manual labor, unfortunately. Because remember, what we've done previously is we've set up with our hub connection, if we again look at, say, the original WPF, which we've got there, we set up the separate hub connections on one, on drawn, and so forth. It would be really nice if there were a way in SignalR of not having an on that responds to a particular message, but have a general purpose on that will just tell you what the message is as a parameter, because then we could forward them in one function from here in the worker to the WPF client. But I cannot find a way to do that. It does not seem possible. We've always got to put the individual responses in there. which is a bit of a shame, even though they should be fairly straightforward. But what we're therefore going to have to do is we will grab all of these just to save a load of typing. So we're going to take all of those from the waiting for player down all the way through to the 1. Copy those, paste them in here, and then eviscerate them. So we're going to take out all of the content because our content is going to be much simpler, even though it's exactly those same messages that we want to be responding to. So can't avoid having those individual ones in there. But then what we need to do when these messages come in is we need to just send them off to the WPF, and we do that with our stream out. And so we can just do a stream out dot write line. And then what we're going to do in here is again use serialization. So we're going to say JSON serializer dot serialize, because remember we're deserializing at the other end as we saw in there. So this is what we're deserializing, and we know that what we need in here is going to have a method and it's going to have args. Again, we can do that with an anonymous object. So we'll just say new, and then because I've got a type method in here, this is why I don't need to worry about the case sensitivity. The method is always going to be the name that we've got in there. That's why it'd be much nicer if we could do this just with a parameter, but we can't. And then the args in this case is going to be empty, so we can just say array.empty, and then it's going to be an empty array of strings. And so that is what's going to be sent off there. And then the others are going to be pretty much the same. So let's just copy that, paste it into there. Got to change the name of the method, and then the args in this case are going to be slightly different. So we're going to have to say new string array, and then in curly braces, it's just going to be player 1, player 2, and game ID. So just those parameters we had coming in there. And then the next one, let's pop that in there. Change the name to pending, and then change that just to waiting for. And then the next one, change that to drawn, and change that to explanation, comma scores. And then finally, change that to 1 and change that to winner explanation scores. Okay, and that should be everything working. Let's just work our way through that. So we're sitting in here in the loop in the execute async. A message comes in from the WPF. We deserialize that and then just use that to send the method and the arguments off to the SignalR hub. Then if anything comes back in from the SignalR hub, it's going to be on one of these ons. So we just serialize that message, put it into the stream out, and then back on the WPF in our worker service proxy, that's going to be picked up here. We deserialize that, and then we use the subscription to call the method that was registered from the WPF, which is done in the game view model, and so the rest of that should behave in the same way. So that should all be working now. I'm just going to comment that out because we shouldn't need to debug this anymore, and then we'll run up the whole thing. And so we're not getting prompted for the debugger for the sub process. We can see there we've got the WPF there. Just for interest, that's the sub process, but not doing anything very much there. But if we put Harry in here and enter that, and then put Sally in here, then you can see it's all working. We'll do scissors. Your opponent has chosen. Scissors, it's a draw. Paper, rock. We can see it's all working perfectly well. And now we've got the communication between the framework WPF via the .NET 9 worker process, via the SignalR hub, and then out to the JavaScript MVC there. Let's just do a couple of other things. Let's configure that now so we can have communication between the Blazor and the framework WPF. So let's configure startup projects and add in the Blazor client there. And one other thing I'll do, one it'll change, when it's running, we don't really want that console window popping up just giving us information about the worker process. That really should be hidden away. So we can do that pretty simply if we go back to our worker service proxy, and then in there, remember when we started this all up, we had that create no window set to false. Well, let's set that to true now, which is actually the default, but we'll leave it in there. And so now it'll be a little bit tidy. So when we run this up now, you'll notice we've got a command window for our hub, and we've got another one for, over here, our Blazor, but we don't have one at all for the worker service. Not that it's not there, it just hadn't produced a window because of what we did. But then if we drag these two over, There you can see the Blazor client, and there you can see the Framework WPF client. But if we now start playing once again, enter there, put in Sally there, and you can see we've got seamless communication between those two different technologies, .NET 9 for the Blazor, .NET Framework for the WPF, but it could be much more diverse than that, although that's the problem we're solving here. In general, that can be used in all sorts of situations. So there we have it. That's really the end of that whole section of what I wanted to show you. We've seen that idea of the worker service. We've seen how it can be launched from a framework application and how we can use that, communicating via those anonymous pipes and get communication across different systems, different versions of .NET. So I hope you enjoyed that. If there's any other areas related to that you'd like me to go into, because there's lots of loose ends really in there. Some of them I'll probably go into anyway, but if you've got any questions on that, do pop it in the comments. Do click like, do subscribe, and I'll see you next time.